All right, for December 2nd's lesson, this is going to be Unit 7, Lesson 7, or if we're counting in order, Lesson 5 or 4, I can't remember. We're going to start off with bell work, and let's review what we already know. So we're asked how many asymptotic discontinuities are present in this function. So what we know is that we cannot divide by 0. So any fraction, any rational number, and we have a rational number here, 0 cannot be in the denominator. So x minus 2 times x plus 4 cannot equal to 0. We'll have an asymptote, or in other words, a line where the graph approaches but never touches, or we'll have a hole. All right, so it's already factored. We're going to set each factor equal to 0. So at x minus 2 equals 0, if we solve for x is going to equal to 2. So we'll have an asymptote here, because if we put 2 in here, 2 minus 2 is 0. 0 times this expression, x plus 4, gives us 0, which we cannot have. Okay, now we're going to take x plus 4, set that equal to 0, subtract 4 from both sides. Okay, that's going to be 0. X is equal to negative 4. So here's our other asymptote. So there are 2. You can see that it is factored into 2 factors. So if either of those is equal to 0, we'll have an asymptote. So the answer is 2. All right, looking at the second part. Make sure that we can see it. All right, this time the denominator is not factored. So we need to look at these 3 terms and see what they have in common. Okay, they all have an x in them, so I'm going to factor out an x. The least common multiple, x, x, and x. So we're going to divide an x out. Okay, when we divide and we have exponents with the same base, you subtract. So 3 minus 1 is x squared. We have 3 on the top, divide 1 out, we're left with 2. All right, now we have plus, and then we have the 8, and then x squared divided by x to the first power. That will leave us with x to the first power. And then lastly, we have 15x over x. X over x is 1, that cancels. So you have plus 15 here. So we've factored it this far. Now we're going to factor the 15 into 1 times 15. That multiplies to give us 15. But when we add 15 to 1, we get 16, not 8. We're looking for 8. So I can't divide it by 2, but I can divide by 3. 3 goes into 15 5 times. 5 times 3 is 15. 5 plus 3 is 8. So now we've hit our factors. Let's go ahead and write it as x plus 3 and x plus 5. And then we already factored that x out. And here's my clue. It's a cubic, so I should have 3 solutions. Okay, this is 2 solutions. This is 2. This is 1 solution. I have 3. So we'll set that first factor equal to 0. So x is equal to 0 is our first solution right here. Set this second factor, x plus 3, equal to 0. Subtract 3 from both sides, and x is equal to negative 3. It's our second solution. And then our third one, set x plus 5 equal to 0. Subtract 5 from both sides, and x is equal to negative 5. So here are our 3 solutions. First one asks us how many, the second one asks us to find those solutions. All right, so for this lesson, okay, oh, this is lesson 8. Let me find lesson 7. Hold on just a minute. All right, lesson 7, we're still looking at rational equations. So our learning targets, I can write rational expressions representing averages to answer questions about the situation. I can write and solve equations with simple rational expressions on each side. So we're going to start off with the bridge. pause the video, read the bridge, and try to solve this equation. So this is going back to Algebra 1, not algebra, but Math 1 and Math 2 to review how to solve equations. All right, I'm going to start with multiplying both sides by the x because I have the variable in the denominator. So I'm going to multiply the left by x. Now I need to put parentheses around the right-hand side and distribute the x when I multiply it on the right-hand side to both terms. So this x over x is 1, and that cancels. So I'm left with 12 equal x times x is x squared minus 1 times x is 1x. Now, if you look at this, this looks like it could be a quadratic equation. But let's move this 12 to the right-hand side by subtracting 12 from both sides. 12 minus 12 is 0. Okay, so 0 is equal to x squared minus x minus 12. We can factor a quadratic or use the quadratic formula. Luckily, this does factor. We want to find two numbers that multiply to give me negative 12. Okay, I'm going to start with 1 and negative 12. Multiplying, I'm going to look at that middle term, it's negative. So this larger absolute value, which is 12, we need to have the negative with that to get that negative middle term when we add. All right, but negative 12 plus 1, when we add those, gives me negative 11. That's not what I'm looking for in the middle. So I'm going to move to 2 times negative 6. That multiplies to give me negative 12, but it adds to give me a negative 4. Now I'm going to try 3 times negative 4. It does multiply to give me negative 12, and it does add to give me negative 1. So I've found the two numbers that I need. So that factors into x plus 3 times x minus 4 equals 0. So you'll set each factor equal to 0 and solve. And I'm just going to skip to the solution. So x is equal to negative 3 for the first solution. For this one, you're going to add 4 to both sides, and you'll get x is equal to 4. So two solutions there. I just ran out of room. I didn't show that last step. I'll move it down a little bit. You could say x plus 3 equals to 0. Subtract 3 from both sides to get your solution, and so forth. All right, now let's move to the warm-up. Okay, stop the video and then write down what do you notice and what do you wonder about A, B, C, and D, this section right here. Then come back. You can notice some things like we have an equation here that is a rational equation. It means we have fractions or ratios on both sides, and we're solving for x. It gives us the solution. We could plug the solution in to see if we have an equation or a true solution, but it gives us the solution. So I notice that I have a solution of x equals to here and here, but this one it's not a rational equation. This one is a rational equation, but the solution is x equals to 5. These are just some things that I noticed. Okay, and then what do I wonder? I wonder how do we solve, and how do we check our answer? But whatever you notice, whatever you wonder, will help you get focused for the lesson that's coming up. All right, we're going to turn to the first activity. Okay, and it's activity 1, rationalizing the price of t-shirts. All right, so the strategy here is to read through the problem and get a general understanding of what the problem is. And then I'm going to get a highlighter, and then we're going to go through and highlight the important information that we need to set up an equation, and also highlight what the question is, so we can go back and try to answer. And this one is broken down into several questions, so I'll just start with the first question. But let's go ahead and read it. As part of a fundraising campaign to ensure reliable bus transportation for students and families, The art club is designing and selling t-shirts. A local business charges $35 to set up their t-shirt printing machine with the design and $4.25 in materials per t-shirt to print. What is the average cost per shirt to print 25 shirts? All right, so it's $35. Here's the question. Let me go ahead and highlight that. What is the average cost to print 25 shirts and 100 shirts? So this is a two-part question. They charge $35 to set up the machine and $4.25 per t-shirt. Okay. All right, so we have to pay that $35 no matter what, plus $4.25 per shirt. And I'm going to use X as the variable for shirts. Okay, so if I have one shirt times $4.25, add it to the $35 that we paid to set up the machine, and that would give us our output, or our Y value, or $39.25 for one shirt. Okay, now we want 25 shirts, so we're going to substitute 25 for X. So use your calculator. 25 times 425 plus 35 equals Y. All right, for activity number 1, first of all, highlight the important information and read through the problem, understand. Eight kilometers per hour. I think I messed up the right-hand side. I'll fix it in just a minute. And we're going to subtract the rate that we're moving against. Okay, this should be 10. Downstream, we're going 10 kilometers per hour. Oh, sorry about this, guys. Trying to write with my mouse is difficult. So this is going to be 10 over 8 plus R. Erase that. All right, now we're going to cross multiply and solve. All right, I'm going to leave it up to you to do that. Okay, because it's just difficult for me to write with my mouse. All right, so 8 plus R equals 5. So 5 times 8 is 40. Let's distribute that 5 to both terms. Plus 5 times R is 5 times R, or 5R. 5R. All right, so that's going to equal to, I'm going to have to move over here to the left, I'm running out of room, and cross multiply this way. And go ahead and distribute that 10 times 8, and then 10 times R, put a minus in between. So that's going to be 80 minus 10R. Sorry, I'm just not good at this mouse writing. All right, that's R. I'm going to put the R right here. All right, and then what I would do is I would add 10 to both sides, 10R. Bring that 10R over here with the 5. That gives us 15R. And then subtract 40 from both sides. 80 minus 40 is 40. So 15R equals 40. And then divide both sides by 15. I'm going to go ahead and let you do that on your calculator, so pause and then come back. Okay, so that's going to give us approximately 2.6 repeating, or 2.7. R is equal to 2.7 kilometers per hour. That's the speed of the river. All right, we have a work problem on activity number 4. These are common. For example, we have Han that can mow the yard in 30 minutes, and Lynn can mow the same yard in 45 minutes. Now, if they were working together, how long would it take them to mow the yard? So our fraction is one job over the time to complete. So we're going to take each of those ratios. So Han can mow the yard in 30 minutes, so he has 1 yard in 30 minutes right here. And then Lynn is 1 yard in 45 minutes. So we're going to add those two together. Okay, so our new ratio, 1 over the time, is going to be 1 over 30 plus 1 over 45. So now using that, we have Jada and Kieran are painting a mural in the front of their school. Well, working alone, it takes Jada 3 hours. So 1 mural in 3 hours for Jada. And Kieran, it takes 1 mural in 6 hours to finish the job. So how many hours would it take them to complete the mural together? Okay, so we're going to add those together. So we need to have a common denominator. Either, however you do this with fractions, you can cross multiply, call that butterfly math, or you can find the common denominator, which would be 6. I'll just use butterfly math. All right, so 1 times 6, I always start on the left. 1 times 6 is 6, plus 1 times 3, we're going to go over here. 1 times 3 is 3, and the common denominator would be 6 times 3. Don't know why I made that a curved line, or 18. So 6 plus 3 is 9. 9 over 18 is 1/2. So that would take them, for one job, it would take them 2 hours working together. Okay, we simply add up the work times together. All right, you can go through this, the rest of this on your own. Okay, look at some of these questions, but I especially want you to go through the scenarios here in the summary and glossary. Highlight an example of what I've highlighted and understand how they're working through the equation. These are word problems. I know that they take us a little bit longer, but highlight the summary and glossary and try to understand what's happening, because you will have some word problems in the test. Not everything, but you'll have a couple. So work through the assignment on pages 8 through 12, questions 1 through 14. Do what you can on your own, and then we'll take about 10 minutes to go over this work before you turn it in on Tuesday.